So I had a few requests to go over some problems from the review packet. I'm going to take care of all of those right now. So the first one was for number 9. First thing I'm going to do here is take care of these powers. When you take a power of a power, you multiply the exponents. But I need to make sure I'm multiplying this quantity h minus k times h. So that is going to look like y to the h squared minus k times h, or hk. So taking care of the next power, we're going to do the same thing. We're going to multiply h plus k times k. That's going to give us y to the hk plus k squared. So we're multiplying our powers. Now we have multiplication with the same base, so we can add our exponents. We can write a single power of y. We're going to have h squared minus hk plus hk plus k squared. And now let's simplify any like terms. Negative hk plus hk is 0. So we end up with y to the h squared plus k squared. So your exponent is that binomial h squared plus k squared. Number 11. Let's take care of all of these powers. So starting with c cubed squared, multiply the exponents, and that gives us c to the 6th over d to the 4th squared would be d to the 8th. And now we're going to cube everything inside the second parentheses. Now this negative, remember, is a negative 1. So when I bring negative 1 to the third, it's still going to be negative 1. And then we're going to have c cubed d cubed over h cubed. So you distribute that power to each term. Let's go ahead and multiply across with this fraction. So right across the denominators, I'm going to multiply c to the 6th times negative c cubed d cubed. We can do that by adding the exponents for the base of c. So c to the 6th times c to the 3rd is going to be c to the 9th. So we're going to have negative 1, or just negative c to the 9th d to the 3rd over d to the 8th h cubed. So multiplying the denominators there. Last thing we can do is notice that we have a base of d in the numerator and the denominator. We can bring those together by subtracting exponents. But notice that the greater of those exponents is in the denominator. So that means we're going to get a negative exponent. So if we subtracted from the numerator, 3 minus 8 is going to give us negative 5. So we know we're going to have d to the positive 5 in the denominator. So we're going to end up with negative c to the 9th over d to the 5th h cubed. Alright, looking at number 12. So this is similar to one of our homework problems. We just have to be really careful when it comes to subtracting the exponents. Let's first simplify that denominator. So we have a to the 2m, b to the 2m plus 1 over a to the 2m, b to the 2m. So all I did was distribute that power in the denominator by multiplying the exponents. Now we have common bases here. In fact, a to the 2m divided by a to the 2m, you can cancel right out. Those are common factors. Or if you subtracted 2m minus 2m, that's a to the 0, which is 1, so it cancels out. Now we need to subtract exponents for b. We have b to the 2m plus 1 minus 2m. Well, 2m minus 2m is 0, and we just end up with b to the 1st, or b. Alright, scrolling down, the next question I had was 17. So we're solving the equation. We want to make sure we show all work, and we rewrite each side using the same base first. So how do we do that with 17 when we have 1 on the left side? 1 equals 3 to the 5x minus 2. Can I write 1 as a power of 3? There's no way to rewrite that power on the right side as anything else, so can I write 1 as a power of 3? And if you remember your exponent rules, a to the 0 equals 1. Anything to the 0 is 1. So you can rewrite 1 using any base. So let's use 3 to the 0. So 3 to the 0 equals 3 to the 5x minus 2. And now we just have to set our exponents equal. 0 equals 5x minus 2. That will give us 5x equals 2, and x must be 2/5. Again, when we solve equations, when we're looking for a solution set, we use set notation in our answers. All right, 18. We can rewrite 125 as a power of 5. 125 is 5 to the 3rd. So we have 5 to the 1 minus 3x equals 5 to the 3rd. Set our exponents equal. 1 minus 3x equals 3. Subtract 1, so negative 3x equals 2, and x must be negative 2/3. And then 19. So we have 3 different bases here. I see a 16, a 4, and a 2. We can write each of those as a power of 2. So I'm going to start rewriting. So 2 to the negative 3x times 4 is 2 squared, but I need to raise that to the x, equals 1 over 2 to the 4th. Let's simplify the left side now. We can write that as a single power of 2. So we have 2 to the negative 3x times 2 to the 2x, multiplying those exponents. And 1 over 2 to the 4th we can write as 2 to the negative 4. One more step on the left. Let's add those exponents. Negative 3x plus 2x gives me negative x. So we have 2 to the negative x equals 2 to the negative 4. So negative x must equal negative 4, and x must be positive 4. And I think that was it for the questions so far. If you have any other questions, just let me know, and I will find some time to help you out.